For months, astronomers believed 3I Atlas was just another cosmic passerby, a cold wanderer sliding through our system with the indifference of a stone carried by a river that doesn't know where it's going. It was small, it was distant, it was fast, and although it was mysterious, it wasn't supposed to be consequential. But then the data began to whisper, and those whispers became patterns, and those patterns became something far more unsettling. A deviation, tiny but real, a change in its trajectory by nearly 100,000 kilometers, a shift so mathematically improbable it shook the confidence of even the most conservative orbital analysts. And the worst part? This shift didn't fling the object away into empty space or send it tumbling unpredictably. No, it nudged it with surgical precision toward the invisible edge of Jupiter's gravitational kingdom, the Hill sphere, a place where the planet's influence overpowers the sun's and where objects can linger as if caught in a silent gravitational web designed to hold them indefinitely. This was not supposed to happen. Not naturally, not easily, not statistically. The probability of such a perfect rendezvous is 1 in 26,000, a number so low it becomes less like chance and more like choreography. And when you add the other mysteries, the tiny nucleus no bigger than the Vatican, the enormous coma stretching hundreds of thousands of kilometers in every direction, the survival of a solar encounter that should have torn it apart, the blurry early images that fueled speculation, the unusual composition heavy in CO2, the tail that refuses to behave like tails normally do, everything begins to feel like a puzzle whose pieces were never meant to be separated. Yet here they are, floating before us, demanding to be assembled. Now, we are going to dive into the story of 3I Atlas, its survival, its impossible navigational precision, and why some scientists, including Avi Loeb, believe that what we're witnessing may not be random at all. By the end of this video, you might see Jupiter not as a planet waiting silently in the dark, but as a destination, and 3I Atlas not as a comet, but as a messenger. The shift was small enough to ignore at first, a curve barely distinguishable from noise, but as astronomers fed fresh observational data into their orbital models, the deviation refused to disappear. Instead, it crystallized into something chillingly consistent. 3I Atlas had changed course by roughly 100,000 kilometers during its perihelion passage, the exact moment when the object endured the sun's fiercest heat. This shouldn't have been a moment of control, it should have been chaos. Solar radiation melts ice, triggers violent jets of sublimating gases, destabilizes fragile interstellar bodies. Yet what Atlas did was not chaotic. Its shift was not random. It was directional, smooth, and aligned with a new path that pointed almost exactly toward the outer fringe of Jupiter's Hill sphere. And here lies the statistical horror. The probability that a random interstellar visitor not only survives a close solar encounter, but also alters its trajectory enough to line up nearly perfectly with Jupiter's gravitational boundary is 0.000385%. When probabilities drop that low, you stop thinking about chance and begin thinking about intention, or at the very least, unknown dynamics at play. Every known comet from our own solar system suffers when approaching the sun. They crack, they fracture, their nuclei burst under thermal stress like frozen stones thrown into a bonfire. Even large, dense comets rarely emerge unscathed. Yet 3I Atlas, already tiny, barely 1 kilometer wide, should have been even more vulnerable. Instead, it emerged from its solar encounter not weakened, not broken, not shedding pieces, but intact. Perfectly intact. This survival isn't just curious, it's unprecedented. Scientists initially believed Atlas had disintegrated when blurry images misidentified another comet, K1 Atlas, as the fragmented remains of our interstellar visitor. But once the mistake was corrected, astronomers realized the truth was even more disturbing. 3I Atlas had endured the kind of heat and tidal forces that should have been its death sentence. What kind of structure holds together that strongly? What kind of material resists that kind of stress? Why is a nucleus so small behaving like something engineered rather than something assembled haphazardly in the icy outskirts of a distant system? Initial assumptions painted Atlas as a massive interstellar giant, but those assumptions fell apart once better telescopes observed it. Beneath its extraordinary coma lies a nucleus so small it almost defies belief, less than a kilometer in diameter, comparable to the size of the Vatican. This discovery rewrites everything. A nucleus this small shouldn't produce such a colossal coma unless its composition is saturated with volatile ices far richer than anything found in local comets. And this raises questions that cut into the very bone of planetary science. How did such a tiny object survive the Sun? How does such a small core generate a coma more than twice the diameter of Earth? What kind of chemistry is at play? When an interstellar object carries characteristics never seen in our system, it becomes a messenger from another kind of planetary nursery, one where conditions create structures and behaviors we were never prepared to observe. Perhaps the most bizarre feature of 3I Atlas is not its nucleus, but its atmosphere. A coma of CO2 stretching almost 350,000 kilometers in every direction. This is not normal, not in the slightest. Solar system comets primarily release water vapor, dust, and small amounts of CO2. But Atlas spews carbon dioxide in quantities we've never recorded in any comet before, local or interstellar. This chemical imbalance suggests origins in an environment colder and more extreme than anything around our Sun. Even stranger is the way the coma behaves. It doesn't react like a chaotic plume of gas, but instead forms a steady, structured envelope, almost as if something about the object regulates its outgassing. This is why scientists argue over whether the object is natural or something else entirely, because nature tends to be messy, yet Atlas appears to be following a recipe we don't understand. One of the earliest controversies around Atlas involved its photographs. NASA released images so blurry, so featureless, they looked more like smudges on a lens than a cosmic visitor. But these images came from instruments never designed to track a fast, faint interstellar object. They recorded data, not aesthetics. However, the delay in releasing the photos, partially caused by the US government shutdown, fueled an avalanche of speculation. Why were the images so bad? Why were they late? Why did they show nothing? Once better telescopes, Hubble, Webb, Vera Rubin Observatory, looked at Atlas, the truth became clearer. The nucleus was simply too small to resolve sharply, and the coma too large and diffuse to offer contrast. But even in high-resolution images, something disturbing remains. The tail of Atlas does not resemble any cometary tail we've catalogued. Its curvature, its density distribution, and its alignment with the Sun's radiation all deviate from expected behavior. A tail that refuses to obey physics is not a tail, it's a clue. Atlas is only the third confirmed interstellar object to enter our solar system after Oumuamua and Borisov. And like its predecessors, it brings more questions than answers. Borisov behaved like a comet but was unusually volatile. Oumuamua behaved like nothing at all, accelerating without visible outgassing and spinning like a flattened shard of metal. Atlas combines traits from both. It has the hyperbolic path of an interstellar traveler, the chemical oddities of a foreign comet, and the dynamical weirdness of an object that does not behave according to natural expectations. When you combine hyperbolic velocity, survivability, tiny size, massive coma, and trajectory shifts, you no longer feel like you're studying a comet. You feel like you're studying a question. Atlas's origin point traces back toward the constellation Sagittarius, a region near the galactic core where interstellar density rises and star formation histories become chaotic. Whatever birthed Atlas wasn't like our Sun. It came from a place where chemistry and gravitational forces shape objects under unfamiliar rules. Its velocity ensures it was never bound to our system. It flew in from another star and will fly out again. And yet, before leaving, it seems determined, consciously or not, to brush the gravitational influence of Jupiter. This is what unsettles astronomers the most. Visitors don't take scenic detours. They pass through. They don't correct course. They don't aim. 1 in 26,000. That is the chance that a comet, any comet, much less an interstellar one, would pass within the exact border of Jupiter's Hill sphere by coincidence. 1 in 26,000 is not just small. It is narratively suspicious. It feels like rolling a die and watching it land on its edge, perfectly balanced, over and over again. It feels like nature leaving breadcrumbs to something we haven't acknowledged yet. It feels like intention. Scientists don't like that word, but probabilities don't lie. During its closest approach to the Sun, Atlas experienced a non-gravitational acceleration. NASA attributes this to natural jets of gas escaping from its surface, normal cometary behavior. But the vector and magnitude of this push were so precise that they aligned the object almost perfectly with Jupiter's Hill sphere. The sun's heat should have caused chaotic bursts, not propulsion. Yet what occurred appears to be the equivalent of a course correction. And what makes it eerier is the timing. It happened while Atlas was hidden behind the sun, out of our direct observational reach. Decisions made in the dark always raise eyebrows. Avi Loeb asks a question that seems absurd until you consider the data. If Atlas is not acting randomly, then why Jupiter? His reasoning is simple yet chilling. Jupiter is the gravitational powerhouse of the solar system. Its Hill sphere is enormous. Its Lagrange points are stable. Its location is visible from any point in the galaxy. If an advanced civilization wanted to deploy observational probes silently and efficiently, they would use Jupiter, not Earth, not Mars, but the gas giant whose gravity could capture or stabilize these probes for millennia. In this interpretation, Jupiter becomes a cosmic harbor, and Atlas becomes a delivery vessel. On March 16, 2026, Atlas will glide within roughly 53.4 million kilometers of Jupiter, almost identical to the radius of its Hill sphere on that date. This alignment is too perfect to ignore. If Atlas were natural, this would be the single most extraordinary cometary coincidence ever recorded. If it were artificial, this would be the ideal insertion point for releasing something, small probes, autonomous devices, dormant sensors, into gravitational conditions that require almost no energy to exploit. The Hill sphere is not just a boundary, it is an opportunity. Loeb speculates that Atlas could be positioned to release sondas, technological probes, into Jupiter's gravitational edge. These wouldn't be Hollywood saucers or glowing orbs. They would be silent, inert devices designed to activate only when needed. A civilization advanced enough to build such things would not waste energy sending active spacecraft. They would hide them inside natural-looking objects, letting physics do the work. And if Atlas releases anything, we might not detect it immediately. They could be microscopic, metallic, dark, cold, invisible. The more the orbit is recalculated, the more perfect the alignment becomes. The deviation is not drifting, it is tightening. The path is not wandering, it is focusing. This is the kind of behavior that points to either a natural phenomenon we do not yet understand, or something far more intentional. Even skeptics struggle to explain why so many independent anomalies converge toward the same outcome. At some point, coincidence stops being coincidence. Not all scientists embrace exotic theories. NASA maintains that the trajectory can still be explained through natural, albeit extreme, cometary behavior. The outgassing models, while stretched to their limit, remain technically viable. The probability of a near pass to Jupiter's Hill sphere, while low, is not impossible. And the survival of the Sun, while unusual, does not prove artificiality. The spectroscopic data expected during the December 19, 2025 flyby will reveal whether the jet patterns and chemical compositions match natural comet activity. If they do, the mystery collapses into an extraordinary but natural case. If they don't, then the story changes for all time. We stand on the brink of an astronomical revelation. Every update brings Atlas closer to Jupiter's gravitational frontier. Every new image exposes another inconsistency. Every revised model tightens the trajectory. Soon, we will either confirm this object as a natural miracle of interstellar chemistry or something far more provocative, a visitor with purpose, a messenger with design, a courier carrying secrets older than our sun. In the end, everything returns to one singular fact. 3I Atlas is on its way to Jupiter, and it should not be. Not by chance, not by physics, not by probability. It survived the sun when it shouldn't have. It remains intact when it shouldn't be. Its nucleus is tiny when it shouldn't produce such a coma. Its acceleration is precise when it shouldn't be controlled. And now it approaches the gravitational edge of the largest planet in the solar system with a precision that feels scripted. If nothing happens, we expand our understanding of comets. If something happens, then humanity will have to expand its understanding of itself. And now, after examining every anomaly, every deviation, every improbable number, and every unanswered question surrounding 3I Atlas, We arrive at a place that feels less like an ending and more like a threshold, a narrow doorway between what we think we know about the universe and what the universe has been quietly trying to tell us for years. Because when you gather all the evidence, the 100,000-kilometer course correction near the sun, the survival that contradicts comet physics, the tiny nucleus wrapped inside a colossal CO2 atmosphere, the tail that refuses to follow solar wind logic, the blurry early images that conceal more than they reveal, the perfect alignment with Jupiter's Hill sphere, the 1 in 26,000 probability, and the whispers of possible sondas waiting to be released, you begin to realize that this story was never really about a comet. It was about perspective, about the way the cosmos sometimes forces us to look again at things we too quickly label as random or harmless or insignificant, when in reality they might be anything but. 3I Atlas challenges us because it stands at the crossroads between the explainable and the impossible. NASA's models still fit technically within the realm of natural physics, but only if every extreme occurs at once. Extreme sublimation, extreme statistical coincidence, extreme survivability, extreme chemical composition, and at some point one must ask whether stacking every improbable explanation on the same fragile tower truly serves the truth or simply protects our comfort. And on the other side of that tower stands a more daring possibility, that Atlas is not acting alone, that its trajectory, its chemistry, its acceleration, even its timing might belong to a plan older and more deliberate than anything our species has ever encountered. We don't need to jump to fantasies of alien motherships or sentient machines to acknowledge this possibility. Something far simpler is enough. A probe hidden inside an object designed to mimic nature, a passive messenger drifting for centuries across interstellar space, a silent courier that only activates when a gravitational giant like Jupiter enters its field of opportunity. But the truth is that right now, in this moment, we don't know. We don't know if Atlas is simply the most extraordinary comet in recorded history or a visitor with purpose. We don't know if its approach to Jupiter will be an astronomical coincidence or a cosmic appointment. We don't know if March 2026 will come and go quietly, or if something will be left behind in Jupiter's gravitational wake, something small, dark, silent, and patient, watching the solar system the way we watch the stars. What we do know is that 3I Atlas has already changed us, because objects like this don't just rewrite orbital charts. They rewrite the way we look at the universe, the way we look at our instruments, and the way we look at ourselves. And perhaps that is the real message hidden beneath its coma and tail, that the universe is not a place of silence but of signals, and that sometimes those signals arrive wrapped in ice, disguised as coincidence, disguised as something we think we've seen before but never truly understood. So as we wait for the December 2025 flyby, as astronomers prepare their spectrometers and telescopes, and as the countdown toward Jupiter's Hill sphere ticks silently in the dark, one truth remains unavoidable. We are not just observers to this story, we are participants. Because whether Atlas behaves naturally or reveals something unimaginable, the result will push humanity one step deeper into the cosmic conversation. The question is not whether we're ready for that conversation. The question is whether the conversation has, in fact, already begun. And if this journey through the unknown has captivated you, if it made you question the nature of cosmic visitors, if it left you staring at the sky with a different kind of curiosity, or even a hint of unease, then don't let the story end here. Subscribe so you don't miss the next update in this unfolding mystery. Turn on notifications because Atlas is moving fast, and the next anomaly could break at any moment. Share this video with someone who needs to know what's happening above our heads, someone who still believes comets are simple and coincidences are harmless. And leave a comment telling me what you think. Is 3I Atlas just an extraordinary comet, or the first page of a much larger message?